Why are sunrise and sunset times different in different parts of the world? The times of sunrise and sunset change constantly throughout the year. The sun does not always rise and set at the same time every day. The time varies according to the season, geographical location, and other factors. This means that even if two locations are close to each other, their sunrise and sunset times may differ slightly. This can make planning activities during the day challenging. It's all in the timing, a wise man once said. If you ask a sky watcher, they'll tell you that it's because of the Earth's rotation and the position of the sun, but if you ask me, it's because of the Earth's incredible capacity to deliver us the most gorgeous sunrises and sunsets, no matter where you are. Hello everyone, welcome back to Zeey. Subscribe to our channel and ring the bell so you will receive our daily videos. The reason for different regions on Earth have varied sunrise and sunset times is due to a combination of two factors. The tilt of the Earth and its orbit around the sun. The Earth rotates like a top. A full spin takes 24 hours, which is equivalent to 1 day. The Earth also orbits the sun once a year, which is equivalent to a 365-day journey. Our planet spins at an angle of 23.5 degrees in order to complete one complete orbit around the sun. The Earth is shaped like a ball with a line running through the middle from top to bottom. The sun is up for a long time in one half of the ball, but only for a brief time in the other. That is why the sun rises and sets at different times in different parts of the world. The tilt of the Earth is the primary reason of variations in dawn and sunset times around the world. Because the Earth's axis is slightly tilted relative to its orbit around the sun, the northern and southern hemispheres receive varying quantities of sunlight throughout the year. Seasons exist for this reason. This tilt also influences the length of day and night as well as the duration of the day cycle. The angle of the Earth's tilt in relation to the sun's beams determines the position of the sun in the sky at any particular time. The Earth's orbit around the sun also has a role in determining when sunrise and sunset occur. The Earth's orbit is slightly elliptical, which means that its distance from the sun varies during the year. This influences how much sunshine the Earth receives and how long the days and nights last. Because of the Earth's tilt and orbit around the sun, dawn and sunset times vary around the planet. Because the Earth revolves, different places of the planet have varying periods of day and night. This is why sunrise and sunset times vary by location. Each area has its own unique mix of the Earth's tilt and orbit around the sun. The fact that sunrise and sunset times change from place to place on Earth indicates that the Earth is always changing and evolving. It also means that each region has its own distinct culture and way of life, dependent on the amount of light it receives. Did you know that there are some places on Earth that have constant daylight? It is nearly never dark. Because of the Earth's tilt and revolution around its axis, the sun never sets in certain regions, resulting in the sun being above the horizon for days or even months in areas above or below the Arctic Circle. The winter solstice occurs on December 21st or 22, resulting in the shortest day and longest night of the year. Even though it may be difficult to see immediately away, the daylight hours, the time between sunrise and sunset, increase longer and longer after the winter solstice. The orbit is elliptical rather than circular, with the Earth's axis of rotation at an angle to the plane of the orbit. As the Earth moves around its orbit, the times of dawn and sunset vary. An astronomical almanac or a calendar depicting sunrise and sunset times show that the sun does not rise and set by a fixed amount of minutes each morning and evening. The sun rises a little sooner each day at the start of the year. For example, in Berlin, the sun rose 25 minutes earlier than on January 1st but set 45 minutes later. Although the shift is not symmetrical, solar noon, the time when the sun is at its highest in the sky, still occurs halfway between sunrise and sunset. The time between sunrise and solar noon remains largely constant, as does the period between solar noon and sunset. The sun rises slightly earlier each day, yet reaches its highest point in the sky at midday. This results in a progressively rising delay as the days lengthen. What makes this possible? The Earth's orbit around the sun is not exactly round, rather it is slightly elliptical. This means that the speed at which the sun moves across the sky varies from day to day, sometimes faster and sometimes slower. Furthermore, the exact course of the sun varies depending on the season of the year. Because the Earth's axis of rotation is not parallel to its orbit around the sun's path across the sky changes on a daily basis. The northern or southern hemispheres are inclined towards the sun depending on the season, creating variations in the sun's course. You know how our clock abruptly changes time and falls back 1 hour in the winter? This is known as the winter solstice. The winter solstice marks the longest night of the year as well as the official start of winter. So what happens when you mix the longest night and the shortest day? The ideal time to stay up late, cuddle up with your favorite blanket, and watch the sunrise. So what exactly is a solstice? The seasons change astronomically at particular periods of the year, which are the 2 solstices in June and December and the 2 equinoxes in March and September, due to a combination of factors, the relationship between the Earth and the Sun as well as the tilt of the Earth's axis. The summer solstice, which begins in June in the northern hemisphere, is the longest day of the year with the greatest daylight, whereas the winter solstice, which begins in December in the northern hemisphere and summer in the southern hemisphere, marks the beginning of winter in the northern hemisphere and summer in the southern hemisphere. The name of this phenomenon comes from the Latin words sol for sun and sister for to stand still. Days or weeks may pass without the sun dropping below the horizon in the planet's most northern regions and vice versa in Antarctica. Scientists believe that these dates mark the transition between seasons for all of us on Earth. The solstice has been honored for thousands of years, most famously in the form of Christmas, which incorporates many of the same traditions from old pagan rites. So what exactly is the purpose of seasons? The changing seasons are caused by the Earth's axial tilt, which is 23 degrees. Without it, life on Earth might have evolved differently because to more stable temperatures and climates. Because of this tilt, the northern and southern hemispheres are more or less exposed to the sun's rays throughout the year, resulting in changing temperatures, differing meteorological conditions, and times of increased and decreased light and energy, which we call seasons. The equinoxes occur twice a year in March and September, when the Earth's equator crosses through the same plane as the sun's equator. They represent the start of the spring and fall seasons and are known as equal night because most regions have nearly equal quantities of day and night. One of the most romantic activities one can do to have a magnificent view without even trying is to watch the sunset or sunrise. So let's go a little deeper and explain why our sunsets and sunrises appear the way they do. We wondered how the atmosphere affected sunlight. Our eyes can detect a portion of the sun's emissions known as the visible spectrum, which is an electromagnetic radiation ranging from high-frequency gamma rays to low-frequency radio waves. This visible spectrum, sometimes known as white light, is made up of 7 different wavelengths that are commonly abbreviated as Roigbiv. To summarize, various planets get the same electromagnetic radiation at varying strengths. I'm curious if the hues of the sky and sun differ from planet to world. It should be mentioned that, aside from sunlight, the colors we experience are affected by the medium through which the light travels. When light interacts with distinct particles, it behaves in a variety of ways. When light collides with a particle, it can be absorbed, reflected, or scattered. Scattering of light occurs when particles interact with light, causing some wavelengths to be eliminated and the color we see to change. The quantity of scattering varies on the type of particle involved, with certain particles preferring scattering longer red wavelengths and others preferentially scattering shorter blue wavelengths. For example, in the vacuum of deep space, where there are no particles to impede or absorb light, the sun appears white. Could you explain why sunsets on Earth appear red? It has something to do with Rayleigh scattering, a phenomena in which the particle size is substantially smaller than the wavelength of the light. The minuscule nitrogen and oxygen molecules in our planet's atmosphere scatter blue wavelengths, allowing red wavelengths to reach our eyes by the time the light reaches us. Have you ever pondered what it might be like to see a sunset on another planet? Let's take a little trip to Mars and observe what the sunset looks like there. When we examine the Martian sunset, we can easily notice 2 distinct features, the bluish disk of the sun and the fading blue halo that surrounds it. Let us look at what causes these phenomena. Because the Martian atmosphere filters off the redder wavelengths, the sun appears blue on Mars. Because the dust size on Mars is ideal for scattering red light, these particles scatter red wavelengths more than blue wavelengths, causing sunlight to travel the greatest distance during sunrise or sunset, resulting in a blue disk. This is known as wavelength selective extinction, which refers to the Martian atmosphere's capacity to filter out red light while allowing in blue light. What causes the blue halo that surrounds the sun? Mars' blue halo is created by a combination of wavelength selective extinction and Mie scattering, in which light is scattered in the forward direction, resulting in a concentrated blue halo. In the forward direction, blue light intensity is 6 times that of red light, with the highest intensity at a scattering angle of 10 degrees. The dominance of blue wavelengths declines as the scattering angle increases, and the bluish glow fades into the reddish-gray sky. If you're dissatisfied that the only way to see a blue sunset is to travel to Mars, you'll be relieved to know that they've been observed on Earth as well. It's not very common, but it does happen. Locals in the Krakatoa volcano area stated that the sun and moon had a bluish color for a full month after the eruption in 1883. It was incredible. Reverend Sereno, a bishop in Hawaii, was the first to describe a bluish halo around the sun bordered by a brownish ring. This phenomena has been properly termed the bishop's ring, as it is created by volcanic dust particles ejected into the atmosphere as a result of an eruption. Aside from volcanic eruptions, blue sunsets have been seen on occasion in Arabia's deserts, where dust storms are common. Forest fires can sometimes result in red skies and blue sunsets. One of nature's most stunning gifts is the sunset. The various sunrise and sunset times around the world can be attributed to the Earth's tilt and orbit around the sun. The confluence of these two events results in the spectacular hues seen at the end of the day in the sky. Sunsets appear red due to Rayleigh scattering of sunlight in the atmosphere because the size of particles in the atmosphere is considerably smaller than the wavelength of the light. Blue wavelengths are scattered while red wavelengths reach our vision. These incredible natural occurrences serve as a reminder of our planet's beauty and diversity. This video has come to an end. Thanks for watching, everyone. Don't forget to like and subscribe to keep up with all the intriguing astronomy subjects.